All right, so in this video, we're going to solve equations for a selected variable. Okay, so you see some equations, some formulas here that have multiple variables in them. Sometimes these are called literal equations, okay? And most often, you guys are going to see literal equations in chemistry and physics, okay? So those of you taking chemistry right now, you're going to be working with some of these, maybe not these specifically, but you'll be working with literal equations very soon, if you haven't already, okay? So again, if you've got multiple variables, we need to be able to solve for any of the variables in this literal equation, okay? So we've got A, we've got X, we've got B, we've got C, okay? We're asked to solve for X, but you could just as easily be asked to solve for A, B, or C. And in all honesty, you need to be able to solve for all of those, okay? So we're gonna do these three examples. There's many, many more, like I said. And if you need extra practice, you know, even though these say solve for X, solve for X, solve for R, and if you need the extra practice, you could solve for any of these four, you could solve for any of these four, and you could solve for any of these three, okay? So if you need the practice, by all means, go ahead and let me know if I can help or if I can check your work later on, okay? So let's look at this one. We want to solve for X, okay? Just like you did in Algebra 1 when you first learned how to solve basic linear equations, you want to isolate the X, okay? So we're going to go through our algebraic steps to get X by itself, okay? So I'm going to move the B over to the right side first, and it changes signs, become positive. So AX equals B plus C. And now I'm just going to divide by A because I want to get X by itself. And when I divide by A, I get X equals the sum of B and C divided by A, okay? Once I've got X by itself, I'm finished, all right? And now, no matter what the values of A, B, and C may be, I can plug those into this equation, and it'll be much easier to find different values of X, okay? If I knew A, B, and C, and I kept plugging it in here, I would have to do the same work over and over again to find what X would be. Here, just plug it into this, do some quick math, and I would have all the different values of X that correspond with all the different values of A, B, and C. Okay? All right. In B, we want to get X by itself. Now, I've got two of these X's. Okay, I've got an X in the numerator of this expression. I've got an X in the numerator of this expression. All right? So first thing I want to do is I need to get rid of this A and this B here. All right? And there's a couple ways I can do that. I could get a common denominator, combine these two fractions, and then go about the process of getting X by itself. Okay? In this example, though, what I'm going to do is I'm going to find what that common denominator would be for all three parts of the equation, and I'm going to multiply both sides by that value, okay? So the common denominator here would be A times B, the product of A and B. So if I multiply both sides of the equation by that product, I'm maintaining equivalence, okay? But I'm also eliminating fractions, okay? So let's show that step. I'm going to multiply both sides by AB, okay? So over here, I'm going to distribute. I've got AB times X over A, okay? So that's going to give me, these A's cancel out, and it gives me the product of B and X, so that's why this is BX. When I distribute AB times X over B, the B's cancel out, and that leaves me with the product of A and X, okay? And then on the right side, I've just got the product ABC, okay? So now, I'm solving for X. You've recently gone over factoring. Notice this on the left side here, we've got a GCF of X. So I'm going to take out that X. It leaves me with the sum of B plus A. And the right side hasn't changed any. So I'm closer to getting X by itself. All right, so now I just want to divide by this sum, B plus A. And my final answer is going to be X equals ABC divided by B plus A. Okay? So in this one, we multiplied by the LCD to eliminate fractions. All right. Just to show you a different way, and see here, I'm actually going to get a common denominator on the right side here and go through the process a little bit different way, just so you can see how that might work. All right. So 1 over R equals the sum of 1 over R sub 1 and the 1 over R sub 2. Now notice R sub 1, R sub 2, these are different variables, okay? They have different values, potentially, all right? So my common denominator on the right side here would be the product of R1, R2, okay? So I'm going to multiply this fraction by R2 over R2, and I'm going to multiply this fraction by R1 over R1, okay? So let's clean up this right side a little bit. Left side's still going to be 1 over R. R2 times 1 is R2, divided by my common denominator R1, R2. 1 times R1 is R1 over my same common denominator, all right? So on the right side now, I've got two fractions with the same denominator, so I can combine those numerators, and I get 1 over R equals the sum of R1 and R2 over the product of R1 and R2, okay? Now, we're going to use a rule of proportions here. We've got a ratio here, or a fraction, equal to a ratio or a fraction. So this is technically called a proportion. So there's a rule in proportions where you can flip both sides and equivalence would be maintained, okay? So I'm not going to do any real magical algebra stuff here. I'm just going to use that rule with proportions, and I'm going to take the reciprocal of both sides here, and that proportion is going to maintain its equivalence. So R over 1 becomes R1, R2 divided by R1 plus R2, okay? So we could have worked this problem exactly the same way we did over here, by multiplying by the least common denominator and eliminating fractions right away, okay? But I did want to show you that you could work it another way. You might find this problem easier using the method we used in B. But, you know, when you're solving equations like this, kind of whatever you decide to do in the first step is going to drive what follows. And you need to have all these different tools in your box so you can solve these literal equations the best way for you. All right, so I wanted to show multiple ways to do problems that could be done in the same way. All right, so hopefully that helps. Choose what's best for you and go with it. But the main thing is, if you need extra practice, you've got 3 different equations here that you can solve for multiple variables, and you can get a lot of practice in. All right, good job.